So number 46 from the last homework. The hint I gave was that there are two ways of doing something like this. We could think about this like this, or we could say, oh, hey, look at that. That's the same as this right here. One of these ways is going to be ridiculously hard. One of these ways is going to be much easier. And it turns out that that way is the much easier way. And so it looks like you attempted the first way and then said, wait a minute, or would it be better to go ahead and do this? And yes, this is the way we want to do it. And so now, okay, so I'm thinking, okay, first, outer, inner, last. First gives me y squared. Outer gives me minus y. Inner gives me plus y. Oh, they cancel out. Nice. Minus 1. And that's all cubed. And so I'm just going to rewrite that as y squared minus 1. I'm going to say, yeah, and we could, after having done 1,000 of these, we could identify that as, yeah, that's just y minus, or I'm sorry, y squared minus 1. And so now, here's the thing. This is the thing. With these guys, if you remember this whole Pascal's triangle thing we did before.
Yeah.
This right now, what I am not usually a fan of formulas ever, but this is one of the few that I'm cool with using. Like what we could do, say, all right, in this case, then I know that whatever the first thing is, first needs to be cubed, right? So I'm going to have I can just think about it like this, y squared cubed, and then it's going to be, but here's the problem, right, is with that minus sign right there, that's going to change the signs. It's going to make this one a negative, that one positive, this one a negative. Like we talked about this last time. If this isn't familiar, I'd say just look at the end of our video from last time. But we explained why it gives you that alternating negative, positive when there's a negative right here. And so we could just say, okay, so then it's going to go, and this is kind of how I would think about it. I would say we take the first thing and cube it. Then we take the first thing and square it. Then we take the first thing, and then the first thing is not going to be there. In the first case, the second thing is not going to be there. Then it's going to be the second thing to the first power. Then it's going to be the second thing squared. Finally, it's going to be the second thing to the third power. This, of course, is my y squared, like this, squared. And then the coefficients come in. And this is where, and usually what we do is we say if it's 1, we're just going to forget about it. And then just remember that this is the reason why we get what I call the blinker, right? It blinks on and off. We get negative, not negative, negative, not negative. Well, that's because when negative 1's raised to the first power, that's a negative 1. When it's squared, it's a positive 1. So it basically, you can just think about it as goes away. The negative stays negative, and so you end up with a minus 1. Then we have the coefficients to deal with. So this becomes a minus 3. This is a plus 3, and so on. And then finally, just putting this all together, we would have y squared cubed. What is y squared cubed?
Y to the 5th, right? No, wait.
This is where, and I do this all the time, right? I'm like, wait, what do we do with those exponents? And then what goes in your head is the rule add or multiply? When that happens, think visually. Think, wait a second, what does y squared mean? Well, y squared means y times y. What does something cubed mean? Oh, it means to do it 3 times. And so I have this same picture, y squared, which is y times y. I have that picture 3 times. And so now I'm just counting up the numbers of y's that I have, and I can see I have a total of 6 y's.
Right.
Then my brain goes, oh, that's right. The rule is 3 times 2 in that case, and it gives me 6. So yeah, that's, I almost always think visually. I just imagine, okay, I have 2 y's, and then I repeat that 3. Right, it's 3 times 2 in this case, y to the 6th. Okay. And we're back. Okay, so we just said this was y squared is y times y, and then we have two of those, so y times y and y times y gives me a total of 4 y's. So we have a minus 3 y to the 4th, okay, and then plus 3y squared minus 1, and that is the answer right there. That's all we're looking for. That's what that is. Now, something to note. One of the reasons I'm glad we're talking about this actually is, and sorry, it's all bad. So one of the things to note is that the highest power of y here is y to the 6th. Now, I could have told you that before we ever started anything here, before we just started doing any work. The way I could tell is because I know that whenever I have a binomial or any polynomial and the highest order term, let's say we have a polynomial in z and I have z cubed plus, oh, I don't know, how about 2z plus 1? And I'm going to raise that to the 6th. Actually, I'm not going to do that. We're gonna keep this somewhat simple. I'm going to say, I'm going to raise this to the 3rd power. I can tell you ahead of time that the highest order term is going to be z to the 9th power. Why? How do I know that? Well, what this means, right? Let's just think about this right here. I'm going to go ahead and erase the answer for 46 if you're ready to go.
Yes.
Okay, erasing that. So basically what this means right here is we're doing this thing, multiplying it by itself 3 times. And the first thing, the highest order of z is always going to be z to the 3rd. So we have z to the 3rd plus some stuff. Z to the 3rd plus some stuff. Z to the 3rd plus some stuff. And I know that, okay, what I'm going to have to do is I'm going to multiply these two guys together. And so the z to the 3rd from here is going to jump over and hit everybody who's in here. When that happens, the z to the 3rd is going to hit the z to the 3rd. What's z to the 3rd times z to the 3rd?
Z to the 9th?
No.
Wait.
No. Oh, you're not.
No.
Z to the 3rd times z to the 3rd means z times z times z times z times z times z. How many z's do I have when I do that?
6.
6, right? And so this takes a while. There's a little hump to get over. You have to work with 1,000 of these before it becomes second nature. But this is a mistake that everybody makes, right? It's like, wait, when do I multiply those and when do I not? Well, again, what I imagine when I see this symbol, I imagine I have 3 z's. When I see that symbol, I imagine I have 3 z's. And so when they come together, I just have z times z times z. I have 6 of them. And so the fancy way of writing that is just z to the 6th, right? So, okay, moving on. We have z to the 3rd times z to the 3rd is going to give me z to the 6th. Plus, and then I'll have to go over here. But every one of those is going to be a lower power of z, right? The biggest power of z comes when you get the z to the 3rd times the z to the 3rd. All the other ones are going to be lower. It's going to be, I don't know, maybe like 3z to the 4th or something like that. But right now, that's not what I'm interested in. I don't want an exact thing. I'm just trying to find out what the biggest values of z are going to be. So I know that when I multiply something with z to the 3rd in it times something z to the 3rd in it, since those are the biggest powers, the biggest power I could end up with is a z to the 6th. Mm-hmm. That's all I'm trying to analyze right now. And so then, okay, then I'm going to take that and multiply it by something whose biggest power is z to the 3rd. So again, the z to the 6th is going to jump over and hit everybody in here. And when that happens, what's z to the 6th times z to the 3rd?
Nine.
Z to the 9th, exactly.
Yeah.
That means I take 6 z's and then I bring it over and I multiply it by something with 3 z's. I have a total of 6 z's times 3 z's. Altogether, I have 9 z's. And so, okay, z to the 9th. Then the z to the 6th is going to jump over and hit, I guess it'll be 2z, but he'll only pick up one extra z. That'll be z to the 6th, I guess z to the 7th from there, right? And so on and so forth. You can't get any bigger than that biggest guy right there. And so everything else is going to be another term. It's going to have, I don't know, something else. Maybe it's z to the 7th, whatever, plus something, I don't know, z to another power. But the highest order term is going to be z to the 9th power. And I could tell that because of this type of analysis that I'm doing. So similarly, I could say, well, right here, the biggest value of y that I could expect will be y cubed, really, right? Because this just means take y times y minus 1 times y minus 1 times y minus 1. And then when I go and distribute the y in the first time, the biggest power I'm going to have is y squared. Then I go distribute that in the second time, the biggest power I'll have is y to the cubed. It won't get any bigger than that. So I guess kind of what's going through my head visually here is I see that and go, oh, that means y minus 1 times y minus 1 times y minus 1. There's a singular y in each one. That first and that one's going to give me something with a y squared. Then I'll have a y left over. That'll be the biggest power. The biggest power will come over and give me my new biggest power, which is y cubed. And then a bunch of other terms. Yeah, we get that, right? But the biggest power will be y cubed. Ditto with this second one, right? We'll have y plus 1 times y plus 1, y plus 1. In each case, there's just one singular y there. So when I go and do that multiplication, I'm going to have a bunch of stuff, but the biggest power is going to be y squared. Bunch of other stuff, which I'm not concerned about right now. And then finally, when I finish that multiplication off, I'm going to have a y cubed right there. Bunch of other stuff. But now finally, if I were to work that out, the biggest order thing I would have is a y cubed from there. The biggest power I would have from here is a y cubed from here. So then when I go to multiply those together, I get a y cubed times a y cubed. What's y cubed times y cubed?
Y to the 6th?
Yes, because that means 3 y's, that means 3 y's, and when they come together, we have a total of 6 y's. And that, another thing that's interesting to note is that since there's no number in front of here, right, or the number in front of the y is a 1, and the number in front of this y is a 1, then the only thing that this could be is a 1 y to the 6th. Because how did we get this every time? Well, in every single case, the highest order term came from this far left part, right? In every single case, that always was carrying the coefficient of 1 with it. It can't pick up any more than that, right? And so if you were to multiply all this out, it has to be 1 y cubed left over. Same thing over here. There has to be 1 y cubed left over. And so when you multiply those together to give you your final highest term. So what I was saying is we know that since there's a 1y there, that the very most we could get a 1y cubed out of it. A 1y right there, the very most we're going to get a 1y cubed out of it. Multiplying those together is going to give me 1 y to the 6th. We could play the same game with the other term. Because in the other term, right, that minus 1 is going to be the last thing that gets multiplied. So if we're forgetting about all the stuff in the beginning and we're just saying, well, what's the very last thing that's going to happen? Well, -1 times -1 is what?
1.
There you go, +1. And so if I were to work all this out, I'd have some other stuff over here, which I don't really care about right now, but I would have a +1 right there. Then we'd have a -1 here, -1 here, and we do all the first, outer, inner, last, or in this case, we would have a few terms. And we would do all those first, then we do all the ones with the 2y. And then finally, the very last thing we would do would be a +1 and a -1, giving us a -1 right there. I could play the same game over here and say, okay, when I do this right here, we're going to have something times itself 3 times. It's going to be a +1 in each case. And so I'll go first, outer, inner, last. And then when I do the last, the only thing that's going to be left over is the +1 and +1, leaving me a +1. And then I'll have some other stuff and I'll go, okay, I have 2 terms and I distribute those in, blah, 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 blah. But the very last thing I do is going to be that times that right there, and I will get a +1. So then I could say, in the end, at the very end, what I'm going to get is a -1 times a +1, giving me a -1 like that. And so the point to take away from this, right? It's not that that's how you're going to go calculating these out. It's that in the end, when you get an answer that has something like, I think yours had something like this, some stuff like this. And then finally, you could double check yourself and say, wait a second, hold up. The very biggest value of y that I could expect here should be y to the 6th. Because when I go to do all of this, I'll have 1 y every time, blah, 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 and I'll end up with a y cubed. I'll end up with a y cubed, and so on. And so the biggest thing I should have is a y to the 6th. There in the end, well, the trailing guy is always going to be either a +1 or a -1. So this last thing can't be a 2. It has to be a 1. And we can apply this. Are you following so far?
I think so.
Okay. So we could apply this in other ways now. We could say something like this. So I'm going to go ahead and erase this stuff. Now, that's not exactly this problem. This problem was we changed this to y -1, y +1 cubed. That gave us y squared -1 cubed. And so from here, I could say, well, I have y squared cubed. Y squared is going to get multiplied by itself 3 times. The biggest thing I should have is a y to the 6th. The smallest thing I'm going to have, again, I'm visualizing, I'll have this a bunch of times. And the very last term that we should expect should be something to do with 1. It's either going to be plus or minus. It's going to have to be minus because it's an odd power. And so that way you could just kind of check yourself right there to see if your final answer is going to mesh with your first answer. And again, just to kind of go over, I know that that was the actual answer to the problem. And we did that just a minute ago by using these guys right here. But let's say that I didn't. And I want to go over what you did. So that's the answer. And when you're first starting out, I actually think it's great exercise to just multiply these out. Like until you've multiplied 1,000 of these out, jumping over here to this little mnemonic device or whatever it's called, it might hurt you more than help you. And so what I want to do is just actually compute this. So let's do this. First, outer, inner, last for this guy. What's y squared times y squared?
Oh, y to the 4th.
Y to the 4th. All right, now what does my outside give me?
Minus y to the 2nd.
Yep. What does my inside give me?
Hold on 1 second. I'm writing it out.
Okay.
Y squared. Okay. Y to the 4th minus y to the 2nd. Inside gives you minus y to the 2nd.
Good. And my last?
Mine +1.
+1. Okay. So what I'm going to do is rewrite this. I'm going to group those two terms, giving me y to the 4th minus 2 y squareds plus 1 times y squared minus 1. Now at this point, we're almost done. We got one more multiplication to do. And I looked over your, I don't know exactly what steps you took right here, but I do want to, because one thing I noticed and I want to stress, this is for you. When you did this multiplication, you wrote everything on one line. And you're asking for mistakes in that case. What I like to do is the following. I'm going to go ahead and distribute the first one. In other words, the highest order term I'm going to distribute first. When I multiply that guy by that guy, what do I get? What's y squared times y squared? Oh, dude, watch out. Watch out. Did not copy that right.
Yeah.
That should have been y to the 4th. So what is that guy times that guy?
Y to the 6th.
Y to the 6th. Okay, so I'm just gonna
That's
write.
where I messed up.
Yep, but there's more to it. There's a couple other things you did. Like again, you had it. We'll just.
Yeah.
Okay, so y to the 4th times -1 is what?
Minus y to the 4th.
That's y to the 4th. Okay, now this second one. I'm going to take this second one and distribute him in. And notice, remember, this is written in descending order. This is going to help us out a lot. So what's -2y squared times y squared?
-2y to the 4th.
-2y to the 4th. And that is where I'm going to write him in the same column as the other y to the 4ths.
Oh.
Now, what is the last? When I take this middle term here and distribute him into the last, what do I get?
Plus 2y to the 2nd.
Plus 2y to the 2nd. Okay, now I'm done with the first two terms. Here's the last one, plus 1, and I'm going to distribute it in. So what's plus 1 times y squared?
Y squared.
And now I could put this anywhere I want. How about I put him with the other y squareds? So plus 1 squared. Finally, plus 1 and -1 gives me a what?
-1.
-1. And this is the great thing about writing these in descending order is that this type of thing will be possible every time. And you're going to end up with, well, usually you'll end up with terms that do combine. And as long as you've written them in descending order, they will line up like this as you multiply them through. And what's nice is now we could just say, okay, there's only one y to the 6th. So y to the 6th. What do these guys come out to be?
-3y to the 4th.
-3y to the 4th. What about these guys?
3y squared.
Plus 3y squared. And finally, -1 is just a -1. And we get the same thing if we had done this guy. Although that's supposed to be a 3. That was ugly. That looked Greek. That we end up with the same coefficients, right? But that could be confusing. So yeah, be careful, because I noticed, yeah, you had this times that gave you a y to the 8th. That's an honest mistake, right? Like we've said,
Yeah.
I've made that mistake a billion times myself, right? It's and so I'm going to say for that, like, just be careful, right? Like, try to imagine, wait, what does this mean? 4 y's and 2 y's, and I'm just multiplying them together. I have a total of 6 y's. But for this, right, I did notice that I think on a couple of your lines, you just had everything written all over at once. And that's fine. It's just, this is going to help you. This is going to help you a lot to do it this way.
Yeah.
And if you always keep it in descending order, it's always going to line up nice like this. So that was a point I wanted to bring up right there. Okay. So moving on. We also had, yeah, any last questions with this guy?
No, that makes sense.
Cool, good. So 42. This one was tough. I think it was a challenge problem too.
It was critical thinking.
Critical thinking. Okay, so it said the cube of a certain binomial is 8y cubed minus 36y squared minus 36y squared, then plus 54y, finally minus 27. Find the cube. So in other words, they're saying that this is equal to some binomial. So in other words, we have two terms, A and B, and we're going to cube it. And what we get out of it is this. I think that's probably the hardest part of the question is like, wait, what? Like when I read this,
Yeah.
like, what are you talking about? So what they're saying is that there's some binomial, there's some number here and some number here, so that when you do this to it, this is what pops out. Kind of going back to our original or our previous problem. This is the thing. It's just like when you FOIL something, right? It's so when you FOIL something, you go first, outer, inner, last. And let's say, for instance, you had something like this, or rather, let's say you've FOILed something, because this is what we're going to get into today is factoring, which is basically unfoiling something. And if you have something like this, and let's do, so that's going to be that. Let's say that right there. The first thing we're going to do in order to, because this is what factoring is. We've been going in this direction so far. We've been given two either binomials or two polynomials, multiplying them together and getting something. Now the question is, hey, you did this. What were these? You did this and got this out. What were these original things? And the key here is going to be, like in every case, what we're going to do, the first thing we're going to do is say, well, that had to come from somewhere. That is something times something. What could possibly go here? Kayla, tell me, what could this possibly be?
X and X.
X and X. It has to be, right? I mean, yes, you could say, well, one could be X squared and one could be 1. That's not the game we're playing anymore. Like, we understand that we're trying to undo this thing. And yeah, that's the only place it could have come from. This also, because remember what we're doing here, right? First, outer, inner, last. The first thing is always this thing by itself. The last thing always comes from this last term. That's the way FOIL works. This term, whatever's written last, as long as, yes, you've written it in descending order, then this thing had to have come from this and this. So what times what equals 6?
3, no, 2, wait, yeah.
2 and what?
3.
2 and 3 equals 6. Is there another way I could write 6, something times something? There's one other way, or at least one way. Well, there are infinitely many ways, but there's one way that I'm
3 times 2, 1 times 6.
1 times 6 could be 6. In this case, though, and so this is kind of the thing. We say, well, there's two possibilities here, right? We know that the first has to come from X and X. There's no other way around it. There's no other number in there. It has to be 1X and 1X. 6, though, could either be 1 and 6, or it could be 2 and 3. And so if we just check, we're going to go with our first intuition and say, what about 2 and 3? And we say, okay, well, then, now, remember, this term came from the first multiplication. This term came from the last multiplication. This comes from the addition of the inner and the outer. And I said that backwards. It comes from the addition of the outside and the inside, right? So when we FOIL this thing out. Outside is x times 3, or how about 3x's? The inside is 2 times x, which is 2x's. And we could see that, yeah, when we add those together, we do in fact get a 5 right there, right? Tracking so far?
Yeah.
So, however, let's change this up a little bit. Let's say that we have this problem, or given this problem, and instead of a 5, let's say it were a 7. Now, in this case, we could say, okay, the first, well, we haven't done that. We're going to say, we're given this problem. We have something times something. And it gave us x squared plus 7x plus 6. My first step is going to be, well, let's figure out where this came from. That came from the first multiplication. So this guy and this guy. So what did this and this have to be?
X.
X's. No question about it. It has to be X's because first, outer, inner, last. I do the first, I get x times x. That's the only way to get x squared. Okay, what about the last? Last gives me 6. So again, we're kind of back in the same scenario. It could be 2 and 3, could be 1 and 6. But if I try 2 and 3, like I did the last time, say, okay, well, let's just try 2 and 3. Let's see what happens. 2 and 3. Now, okay, the first works, the last works. And now I'm going to go, okay, inner, outer. So I do my inner multiplication, I get 2 x's. I do my outer multiplication, I get 3 x's. And when I add those together, I have 5. No, it's supposed to be 7 x's. Oh man, maybe if I made one negative, no, because that's a positive number. Maybe if they're both negative, let's just see. If they're both negative, I'll get -2 times -3 is +6. That works. This would be minus 2x, minus 3x is minus, oh no, that doesn't work. Well, that tells me maybe there's another pair that makes 6. I'm going through this because this is like totally what you're going to be doing basically for the rest of your life, especially in the homework tonight. Like this is what we're going to be doing. So we see, okay, my first guess does not work. 2 and 3 are not going to work. Is there another way I can multiply something in order to get 6? Yeah, 1 and 6. So now I'm just going to try that. And as I'm doing this, I just kind of double check along the way. And I say, okay, first, yes, that works. X times x is x squared. Last, 1 times 6 does equal 6. Okay, we're good. Now let's check the outer and the inner. Outer gives me 6x. The inner gives me 1x. Together, I get a total of 7 x's. 7 x's is what I want. And now I'm just going to like kind of double check everything and say, okay, let's just make sure here that when I actually FOIL this guy out, I get what I'm supposed to. So first gives me x squared. Outside gives me plus 6 x's. Inside gives me a plus 1x. Last gives me 1 times 6 is 6. Altogether, I have x squared plus 7 x's plus 6. And that is the thing I started with. I'm good to go. I have found the thing I'm trying to find right there. In other words, that's what we're going to be doing for a long time. Like you're going to do this a lot. And I think of it as unfoiling. Like when you have something like this, something squared, and then plus 1 less to that power, right? So x to the second power, x to the first power, no x's. The way we factor this is we think about it as unfoiling. It's like if I had 2 terms that were multiplied together like this, what would it give me? So, and that's factoring. So how does that relate to our problem number 42? Well, in the same way, like, yeah, it's okay. We don't have a nifty acronym for this, right? We don't have like FOIL or FROZZLE or something like that, but it's the same principle here. Like I was saying earlier, we know that this means, okay, I'm just going to look at the highest order term here. If I have an A in each case, then when I do my first, outer, inner, last with these first terms, the highest order is going to just come from here and stay like that. We're going to have a bunch of other terms that we don't really care about right now. Left right there. And then that thing's going to get multiplied over into here and into there and into there. And we're going to pick up a bunch of other terms that we don't really care about right now. That right there is always going to be whatever number that is cubed. And so I'm looking at this. Basically, the problem I'm trying to solve is this. You're saying you take some number and you cube it, and you're supposed to get 8y cubed. What might that be? Got to have a y in there, right? Kind of like like what we just did when we knew we had basically what we were saying here. It's like if this guy multiplies together to give me y squared, then when I cube it, right, like if it were three things and a y cubed, I know that you'd have to have a y in there, right? What about that 8? So in other words, what I found, I'm saying it's the cube root of, you see what I'm this is the A. I'm trying to figure out what number that has to be right there.
Right.
What times itself 3 times gives me 8?
2.
2. And I believe that should work, right? That's the only way. Like if this were 2y, right? So this is kind of the reasoning that we've applied so far. We're saying if this was 2y, what would have happened? Well, we would have had a 2y right here, and a 2y right here, and a 2y right there. That first would give me 2 times 2 is 4. Y times y is y squared. And so I would have ended up with a 4y squared. And then a bunch of other terms that we don't care about right now. This guy would still be a 2y. Finally, we get my 4y squared times 2y is what?
8y squared. I mean, no, 8y cubed.
8y cubed, which is exactly what we're supposed to have. And so there's when you're talking about cubing a binomial, then whatever this is basically, we're just saying that there's only one way that it could be, is that you took some number, right? And yes, there's 2 numbers in there. There's a 2 and a y, but you took something and cubed it. That is, you multiplied it by itself 3 times, and out came an 8y cubed. Well, the thing has to be a 2y. In other words, could say take the cube root of that. I don't think we've talked too much about roots before, but that's what this means to do. So you following so far how we got that guy right there?
Yes.
Okay. Same thing with the last term, right? Like we did before, right? That last term is always just going to get multiplied by itself. If I wrote this b right here, and I were just keeping track of the last terms, I'd say I have a bunch of terms over here, but that last term comes from b and b, which gives me a b squared. And we'd have 1b left right here. Finally, when I do my final multiplication of the last 2 things that I have, the only thing that's going to be left hanging out here is that b squared times b. So I should have a b cubed. So we need to find a number that when you cube it, it gives you a negative 27. That's what we're trying to find right now. We are trying, we're saying there's some number, b, that when you cube it, you get out a negative 27. What number would that be? So,
No?
huh?
Oh, a negative 27.
A negative 27. Now remember, cubes can be negative. That's perfectly fine. It's squareds to the fourth power, to the sixth power. That's bad. So basically, I know that whatever number I put in here has to be a negative number. There's no way around that. Now, I'm just thinking about, well, what number times itself 3 times is equal to 27?
Negative 3.
3. And this is, as you start to do these, I would suggest that you become really familiar with cubes of like that you know what 2 cubed is, that you know what 3 cubed is, that you know what 4 cubed is. 5 cubed will probably also help you. 6 cubed, you probably won't see, and you might, and when you, if you do, I'm sorry, but just know, just have this in your head. 2 cubed is 8, 3 cubed is 27. Oops. 4 cubed is 64, I think, right? 16 times 4 should be 64. 5 cubed should be 125. So if you see these magic numbers somewhere in your homework, just remember, oh, 8. Oh, that's a cube. 8 is the same thing as 2 cubed. 27, that's 3 cubed. 64 is 4 cubed. It's also 8 squared. So sorry, like that's the thing. We're gonna have to be versatile, right? Sometimes as you're doing your homework and stuff like that, you'll be like, oh, that's a cube, but maybe in this context, we'll want it to be a square. In this context, it's pretty clear what we're looking for, right? It's like, I need some number to be a cubed and to be cubed. And if you just have these in the back of your mind, right? 8, 27, 64, 125, it's gonna make your life a lot easier. So long story short, negative 3 cubed is negative 27. That must be that term right there. Now I'm just going to go ahead and check that this works. Instead of plus b, I'm going to go minus 3 like that. Then this guy would have been a minus 3, and this guy would have been a minus 3. This guy would have been a minus 3. First, outer, inner, last. My last term would have been negative 3 times negative 3 is a positive 9. So I get positive 9 right there. Finally, the very last thing I would have to do is take positive 9 times negative 3. And positive 9 times negative 3 is indeed negative 27. So I think I'm done. I haven't checked that this actually works out, but I think that I'm done right now. I've found something that when I cube the first thing, I get that as it should be. When I cube the last thing, I get that as it should be. So now what I'm going to do is just finally double check that I did this right. Are you tracking so far? Are you feeling good about this? Can I erase?
Yeah.
Okay, cool. So finally, what I'm going to do is say, all right, a couple ways we could do this. There's the lazy way where I go, okay, 1, 1, 1, 2, 1, 1, 3, 3, 1. And then I could go, okay, well, I would have a 1, 3, 3, 1. And it would go 2y cubed. We would have a 3 and a 2y squared, and a 3 and a 2y. Finally, a 1. The other guys would be going down. We would have a 1, and then we would have negative 3, positive 3. Finally, squared. Finally, negative 3 to the third. And yeah, we'll come back to that in a second. Let's just brute force do this guy. 2y minus 3, 2y minus 3, 2y minus 3. Okay, first, outer, inner, last on this first guy. What is first?
4y squared.
Good. What's my outside?
6y minus
minus?
6y
Minus 6y. What about my inside?
minus 6y
Another minus 6y for a total of
minus 12y.
minus 12y. And what do I get with my last?
Plus 9.
Plus 9. There we go. Okay, so I've gotten rid of one of those guys. 2y minus 3. Now I'm going to use my special way that I do this. When I jump over and hit that guy, I'm going to write him right here. And then I'm going to keep going descending order like that. So what's 4y squared times 2y?
8y to the third.
Hey, looking good, right? That sounds good. So now he jumps over and hits the minus 3 to give me what?
Minus 12y squared.
Minus 12y squared. Okay. Now that takes care of that. Now let's go to the negative 12y. Negative 12y jumps over and hits the 2y to give me what?
Negative 24y squared.
There we go, negative 24y squared. And notice how I'm writing him in that column. Now, negative 12y and negative 3 give me what?
36y.
Say positive, did you say 30?
Positive. Yeah.
36y, okay. And now we're done with that one. So now let's do the last one. 9 times 2y give me
18y.
18y. And then finally 9 and negative 3.
Minus 27.
All right. So I'm going to add them all up. 8y cubed is 8y cubed. Minus 24 minus 12 gives me a what?
Minus 36y squared.
This is looking good, right? It's matching up there. Now, what about 36 and 18?
54y.
I believe so. And then finally, minus 27 is just a minus 27. So that's what that problem was all about, right? We need, and it's, I think the hardest part of it was how it's worded. And until you've done this class, it doesn't really make sense what they're asking for, right? This is what they're asking for. They're saying you have some monomial, or however they put it. The cube of a certain binomial is equal to this. This is what they're asking. And I like this one a lot because it really gets into this fact that we've been using, and that your homework has been trying to show you, is that this first term always comes from this right here. And since it's cubed, it's whatever that whole thing is, just cubed. And we can see why that has to be the case. That last term always comes from whatever that last thing is, and finally it just gets cubed in the end. And this is going to help us to undo all of this stuff, which is what we're doing today. So am I good to move on?
I think I actually got the answer correct.
Oh, really?
I just don't know how to. Yeah, I just didn't know exactly how to show my work.
Cool.
Like, if you look at my problem, it's kind of all over the place, but I actually got the answer correct.
Cool. Awesome.
So,
yeah, I just glanced over the stuff. I didn't have time with Peter and all that this morning. So, but I did want to go over that because it really goes into what we're going to be doing today, which we're going to have to hurry up on. So 5.4, did you read 5.4?
I glanced over it.
Okay.
Yes.
Yeah, not much. So they make a big stink about finding the greatest common factor. So when we're factoring things, we're thinking about basically undoing multiplication of stuff, right? And so if we have, say, and they give us a couple examples. Let's look at this one right here, 9y to the fourth. 9y to the 4th minus 15y cubed plus 3y squared. And they say identify the common factor. In fact, there's a big block in your homework that says identify the greatest common factor. And I'm not assigning any of that because that leads you to believe that, at least the way that it makes it sound is like that this is something you do in your head before you do any work. And I hate that. That's not how I think about this at all. So there is a greatest common factor in here. In other words, we could think about, and I call it pulling out stuff. So instead of, it's basically the opposite of multiplication. So first thing I notice is that there are y's in every single one of these, right? Every single one of these has at least 2 y's in it. So I could, what we call, factor out a y, if I were so inclined. I could say, well, this is the same thing as if I had originally this guy right here, and I just wrote it this way. Like if I started with this right here, I would just take this and multiply this y into there. This y would go into here. This y would go into here, and I would end up with exactly that right there. Do you believe that? Does that make sense?
Yes.
Yeah, that is really straightforward, right? Now, am I done? Can I pull out another y? Yeah, there is at least one y in every single one of these terms. And so we could say, yeah, we could pull out another y. And so what I'm going to do is I'm just going to write it like this and say, okay. And what I'm imagining here is kind of the inverse of multiplying. That's exactly what it is. It's as though, as I'm writing this, I'm thinking, well, and I write 9y squared, and I say, well, if you pull out a y, this would be the same thing as bringing that y back in. And if you did that, well, he would multiply there with the y cubed. Yeah. And then what would be left here if I pulled out a y?
Y.
Just one y would be left over. What about here? What would be left?
3.
Just a 3. Okay, now, and I could actually rewrite this, and I wouldn't write it as y times y, I would write it as y squared. And say, yeah, there's y squared like that. And you notice I'm doing this in steps. Right now, I could have at the very beginning said, well, hold up. There's a y squared, that's bigger than y squared. If you pulled out a y squared, you'd be left with one y. That's bigger than y squared. If you pulled out a y squared, you'd be left with 2 y's. And I could just jump straight to this if I were so inclined. But the thing is, I don't need to identify that that is a common factor. I could just do it in 2 steps. And this is like, this is my point. Like, the book makes it sound like your first step, the very first thing you need to do is identify the common factor. Well, no, you could do this step by step and you'll get there, right? What about this now? Okay, now we're done with the y's. The y's are completely done. Because I can't pull, there's no y here to pull out, right? I can't factor out anything more from here. But what about now? Let's look at the numbers. What is there a number, a multiplicative, right? I'm thinking if I were to break this down into like 15 is 3 times 5, right? If I were to break it into its prime factors, they're even called prime factors, right? Is there a number that's common to every single one of them?
Yes.
What is that number?
3.
3. Exactly, because I noticed that's 3 times 3. That's 5 times 3. That's 3. They have a common factor, so I could pull it out, and this is what I would do. I would say, oh yeah, 3's in every one of them. And so I would write 3y squared out at the front. And then at this point, I'm going to say, well, wait a second. I pulled out a 3, And so what do I need to write here in front of the y squared term?
3.
A 3. And what my brain does is once I write that down, I go, now check it. And I go 3 times 3 is 9. Yes. Okay, I'm good to go. What about here? What do I write for the y term?
5.
Plus or minus?
Minus.
Yeah, good. Minus 5. And then I stop and say, wait, 3 times negative 5 is negative 15. Yes, I'm good to go. What about here? What do I write?
Nothing. 1.
0, a 1. It's like a 0 or a 1 because
Sorry, I meant 1.
Yeah, a 1. So plus 1. And then after I've done that, I go, wait, 3 times 1 is 3. Yes, I haven't changed this at all. This is still the same thing as this, which is still the same thing as that, which is that. And then finally, I could just double check and say, if I took this 3y squared and multiplied him in, I would have 9y to the 4th, check. I would have 3 and negative 5 make negative 15. Y squared and 1y give me a y cubed. Check. 3y squared and the 1 up 3y squared. Yep, right there. And so I'm good to go. And I've done that. Thing is, it makes it sound like you need to identify this before you do anything else. It's like identify the greatest common factor. Or you could just do it in bits. It's like saying you have the number 12 and you need to break it into its prime factors. You could either just know what they are, or you could say, well, 12 is an even number. So 12 is 2 times 6. Okay, that's step 1. What about 6? Is that an even? Oh, 6 is an even number. So I could rewrite 6 as 2 times 3. Oh, I'm done, So it's not that I knew that 12 was 2 times 2 times 3. It's that I took it one step at a time and I just kind of popped out factors as I went along. It's the same thing that we're doing here. We're saying, hey, I noticed that there's a common factor in everything. I could pull one of them out. Oh, there's still a common factor. I could pull the next one out. Oh, there's still, and keep going until finally I could see that's not going to factor down anymore. So that's what I wanted to say about greatest common factors. We could get there. We don't have to know what it is at first or do it in our head first. Like, I think that's really detrimental to try to do it in your head and then do it. Just do it on paper. Of course, when it's obvious, right? If you have something like this, like if your problem it's like, well, 5x, like that's obvious. I don't need to do this in two steps. I can tell that 5x is in both of them because that's just 5 times 5 and x squared, and that's a 5x. Yeah, and so we don't need to do it step by step and say, oh, let's pull out a 5 first, then pull out the x. Oops, yeah. We could just jump right to the chase if you notice that 5x is a factor. So I'm just saying that we could be versatile here, but don't think like you have to identify the greatest common factor before you even start. You can just do it step by step. Okay. Right. Okay. So now they call these trinomial squares, and I've never heard that before. I mean, that's technically what they are, but you always hear them as being called perfect squares. They use a and b. Let's use a and b. So we're going to go a plus b squared is equal to a squared plus 2ab plus b squared. Why is that? Well, because of first, outer, inner, last, right? When you have an a and a b and an a and a b, when you go first, you get a squared. Outside gives you AB. Inside gives you AB. And so you have AB plus AB, which come out to 2 ABs. And your last gives you a B and a B, which gives you a B squared. Again, first, outer, inner what comes together here, outer, inner get added together, and then last ends up right there. Now, if I had changed this sign to negatives, let's see what we would have had. Minus AB minus AB. We would have, again, A times A is still A squared. The A times the negative B would give me a minus AB. The inside would be A times the negative B gives me a minus AB. And we would have minus 2AB. Finally, my last, what's my last in this case when they're both negative? What's that times that?
B plus B.
Plus, not just B.
Squared.
Squared, right? You'll notice that the only difference between these two, we'll call them formulas, I guess, is that there's a negative sign right here. And so when there's a negative sign right here, if you notice that there's a negative sign right here, there has to be a negative sign right there. In fact, that's probably the last step we're going to think about when we go to write what one of these guys are. And so, okay, this is nice with A's and B's, and okay, we have these two nifty formulas, but how do we apply this? So we call, and by the way, I'm going to forever call these perfect squares. Your book calls them trinomial squares. I call them perfect squares because that's what I've always called them. So let's do a couple examples here. What does this mean? So here's something. We have, it says to factor these guys. We're going to do 2. So x squared plus 14x, and it is a plus 49. Now, when factoring, I'm going to keep this up here as just like a running thing for factoring. There's a few steps. First step is look for common factors. Look for common factors. When I look at this, there's nothing obvious here, like as a common factor, right? Whereas in the one that we did just a second ago with the 9y to the 4th, the y cubed and the y squared, I immediately saw, well, there's y's in every single one of them, and I could pull that out. Here, I'm not seeing anything that's obvious in every single one of them. We have an x squared, we have one x, and then no x's. In fact, he's in descending order, which is nice. Okay, so no common factors. Okay, cool. Now, check for squares. Always look at, like, well, in this case, when you're talking about squares, this is something squared. We're thinking this should be a square of some sort. Hey, buddy. And really, what we're trying to do is unfoil this guy, right? So we imagine that we've just foiled something together. What is the first? So what must go here?
X.
Right? It has to be an X here and one X here. There's no question about that. What about the last? What are my possibilities? Is it a square?
No. Yes.
49 is a square. You want to be familiar with these.
7.
7 squared. 7 squared. And now it turns out that, so yes, this happens to equal 7 squared. So there's no other possibilities. Like when we had 6, it could be 1 times 6, or it could be 2 times 3. In this case, it has to be 7 and 7, right? So I'm just kind of moving along and saying, well, the last has to come out to be 49. The only way to get that is 7 and 7. And so now, as I'm looking at this, I'm thinking, well, now what signs do I put in here? Well, if that's a plus 14, how do I get 14 out of my inside and outside? So what are my outer and inner? I guess I would have a 7x and a 7x. The only way to get a positive 14 is if they're both plus. So it looks like I have to have both of them be pluses right there. And hey, what do you know? That's the same thing as x plus 7 squared. Did you follow what I just did there?
Yes.
Right? So if you identify, and this is what they're saying here. Look, so we could just take an arbitrary polynomial and unfoil it using that reasoning that I just did to factor out a polynomial. Or if you recognize that there are squares there and say, hey, that's a perfect square. That's a perfect square. And so just like before, we had an a plus b squared came out to be a square and a square. And then whatever that times that is, right? But then multiplied by 2. So we said that guy's an x. So if the a is an x, we would have an x right here. And if the b is a 7, which we said we have a 7 squared, we have a 7 right there. I've just plugged in these guys right here. And then we could see, yeah, 2 times that times that, right? 2 times a times b is 14x, right? 2 times 7 is 14, and the x just comes along as an x. And so I could identify like, hey, that's, and so when I mean check for squares, it's kind of like, well, that's a square, and that's 2 times as much as the first square. So I could just jump right here if I wanted to and say, yeah, and then just go back and check it. It's one of the reasons I don't like having formulas and stuff, is that it's going to be, I think, to our benefit to just reason it through and try to find, basically try to unfoil it. A second here. Any questions with that one?
I don't think so.
Okay, so but this is another one though. This is where this is going to be helpful to think about it. Okay, 9x squared minus 30y plus 25. Okay. So in fact, yeah, forget trying to identify perfect squares. That I don't like that at all. I think it would be much better to every time we just try to unfoil this guy. Let's unfoil him. So, okay. Although, yeah. So what about this guy? How do we, is there a way of multiplying something by itself to give me that right there?
Yes.
What is it?
3x.
3x. If this were a 3x, then when I do my first, I would have 3x times 3x is 9x squared. Nice. What about this guy? Is he a perfect square? The last one, 25?
Yes.
Yes. And so what should I put here and here? What times what is 25?
5 times 5.
5 and 5, right? And so this is looking like it's probably a perfect square. Now the question is, what signs should I have right here? And this comes from the outside and the inside. So what I like to do at this point, and you'll notice how I've done this, the order that I did this. I said, what's my first? And I put down a candidate. Then I said, what's my last? That's my candidate right there. Now, it's like, okay, I need to get a minus 30. Oops, that should be an X. I'm so sorry. I'm so sorry. That's got to be confusing. That's impossible.
Slightly.
Right, that's impossible. It's very impossible. So now, this will be better. Now we need to see, okay, outside, inside. what are we going to get? And so this is just what I do. I could see, okay, we'll have a 15x from the outside and a 15x from the inside. Does 15 and 15 combine to make negative 30x?
No. Negative 15 and negative 15.
Negative 15
They
and
both have
negative 15. And so I could see that the only way that's going to work is if I have a minus and a minus right there. That's always my last step. I figure out the signs at the very end. And you're okay. But another thing you could notice is we could think about this as a perfect square and just say, well, hold up, is this a perfect square? If it is, if this is a perfect square, the only way that it can be is we take the square root of that, which would be 3x. We take the square root of that, which would be a 5. And then it's like, well, there's a minus right there. So let's just try that. Because if there's a minus there, there has to be a minus in there. And so then we just kind of square it out and check ourselves and say, okay, first outer, inner, last, 3x minus 5 and 3x minus 5. First gives me 9x squared. Outside gives me minus 15x, another minus 15x from the inside, finally plus 25. And that does give me, yes, 9x squared minus 30x plus 25. And so if you identify, hey, that's a square, just check it and see if it works. Otherwise, you're going to have to go through the reasoning like we did with unfoiling. Okay, so that's perfect squares. Now we have what this is. Oh boy, this is where it gets a little bit confusing. Okay, good to go?
Yes.
Okay. The difference of squares. When you have a difference of squares, that is, you have some number that's a square and you subtract off some other number that's a square. Turns out it's always this guy right here, a plus b, a minus b. Why is that the case? Let's FOIL it and check. First, gives me a times a is a squared. The outer is a times negative b, or how about minus ab? That's my outer. The inner gives me a plus b, so plus ab, my inner. My last gives me a b times a minus b is a minus b squared. And because of this alternating sign here, a minus and a plus, the outer and the inner always cancel out. And so we're just left with, finally, something squared minus something else squared. Now, what you're going to see in your homework is something like this. So you have all this right here?
Yes.
Okay. So what you're going to see is something like this. How about a 9y to the 6th minus 25x squared? And the thing to notice is like, hey, hold up. I can write this as something times itself. Like, yeah, it's a 6, but y cubed squared is, well, y, there's 3 y's, another 3 y's. That's just a total of 6 y's. So the key here is when you have even powers, right? Then you can rewrite that in this term. And we could say, so in this case, I notice that I have a difference of squares. And so I'm thinking, okay, what is that 9 going to go down to? In other words, what's the square root of 9?
3.
3. And so we're going to have a 3. A 3. And then what about the y?
Y.
So imagine you have 6 y's.
2,
Group them into
Wait.
2 equal groups.
3, y cubed.
Y cubed. There you go. Y cubed. Because this is basically what I'm thinking about, right? 6 y's, 2 equal groups will be y cubed and y cubed. If it were y to the 5th, we'd be in bad shape because you can't get that into 2 equal groups. But you can with this guy. That's just a y cubed. Okay. What about 25x squared? What's the square root of 25x squared?
5x.
5x. Exactly. We have a 5x right here. And now I know that since the inner and the outer canceled out, then we'd have to have opposite signs here. One of these has to be a positive, one of these has to be a negative. Again, I'm still unfoiling, like when I have something like this. It's just this is a special case where we have this type of thing, right? And your book gives you this right here, and I don't think it goes in very well. No, it does a couple of examples of how something like this might show up. In fact, yeah, I think they do use y to the 6th. Oh, they do almost exactly the same one that I just did. So this is the idea, is that an even power. So, for instance, you're going to see this in your homework. Am I good to erase this?
Yes.
Okay. Any even power will work. So let's say that I had x to the 30th minus 1. And you say, oh, that can't be factored anymore. Well, hold up. What's half of 30?
15.
15. So x to the 15th. Oh, hey, look at that. Whenever it's even, you could always half it. And it'll always work. Whenever there's a 1, 1 is always 1 squared. So ones always come along, and you'll always have something like that right there. Does that make sense? Let's just FOIL it out to make sure that I've done this right. First gives me x to the 15th, x to the 15th. That's a total of 15 and 15, or 30 x's. Outside gives me a positive x to the 15th. Inside gives me a negative x to the 15th. They cancel out. Finally, last is minus 1 and 1 gives me a minus 1. Yes, that works. Now, here's a big hint for your homework. You're going to have something like this. I'm going to tell you to factor it completely. And so you're going to go, oh, we basically did this in class. I know I take half of this and I get x to the 10th. And then I get x to the 10th. The 1, square root of 1 is 1. Since there's no outers and inners, they must have canceled out. So we have a plus and a minus, and I'm done. I have factored it completely. Can we take half of 10?
Yes.
Yeah, we're not done, are we? We could rewrite this. We could say, well, this guy breaks down into 2 things. Half of 10 is what?
5.
So x to the 5th in each case. And then I just double check and say, yeah, first, outer, inner, last. When I do my first, I'll have 5 x's and 5 x's will come together to give me a total of 10 x's. My outer and my inner are gone, but really what's going on in my head is I'm thinking that is a difference of squares. 10 x to the 10th is just x to the 5th squared. And so plus and minus like that. Now, finally, I've gotten down to an odd number, and it is no longer a square. I can't say that x to the 5th is something squared. That doesn't work because that's an odd number. And so in this case, with this problem right here, I would be done right there.
Okay.
Does that make sense?
Yes.
Okay. Okay. Oh, the final thing that they in this section is factoring by grouping. which is great when you're working on certain problems. In other problems, you'll never ever use factoring by grouping, and especially the way that the book. Ooh, okay, so let me do one example of when you're going to want to do it. So this is number 56. Number 56, they have b cubed minus b squared plus 2b minus 2. I see this and it tells me to factor. So I think, well, are there any common factors in there? No, I'm not common to everything. This has b's, that has b's, that has b, oh, no b's. This has a 2, this has a 2, up, oh, no 2's. I'm done. There's no common factor there. But what we can do is group these things. And we could think about this, and this is what your book shows you how to do. It said, well, try groups of 2. So think about that as a group of 2. And then within these, we could factor out. So what can I factor out of that group right there?
Is squared.
B squared. So I pull out a b squared, and what am I left with on the inside?
B minus 1.
Minus 1. And as I do that, I check and say, well, hold up. Now going back, the b jumps over and gives me b cubed. Yep. B jumps over, gives me minus b squared. Yep, I haven't changed it. What about in this second bit right here? What is common in both of these?
2.
A 2. So I could pull out a 2, and what am I left with?
B minus 1.
B minus 1. And now, oh, this is what we end up with. B minus 1, B minus 1. We could pull out the B minus 1. This is hard to see at first until you've done 1,000 of these. And what am I left with? If I pulled a b minus 1 out of here, what would I be left with right here?
B squared.
B squared. What would I be left with right here?
Plus 2.
Plus 2. This is how you're actually going to use factoring by grouping. And it's usually when you have something to some odd power like this. We try to say, and you might need to regroup. Like it might not always be the case that you do it this way. You might say, you might have taken this original problem right here and regrouped b plus 2b minus b squared minus 2. Oftentimes this is one of the ways to do it. We regroup like this and say, okay, I could pull a b out here like that, and I get b squared plus 2. Here I could pull out, well, it looks just like a -1 from each one, negative positive b squared plus 2. And you'll notice that you actually get the exact same thing. You see how I did that? I factored out a -1 to turn it into minus 2 positives like that.
Yeah.
So then from there I say, oh, I have a common factor of b squared plus 2. And then I would be pulling that out from there. It would leave me with a b. Be pulling it out from there, it would be minus, well, I guess 1, so minus 1. You end up with the same thing. Either way you do it. Sometimes one of the ways will work and the other one won't. I haven't figured that out yet. Just to let you know that that's often, you will see this, and this is something you want to get familiar with. But whenever I do factor by grouping, it's almost always because I have an odd polynomial.
Mm-hmm.
Your book will say, And I don't think I've assigned any of these. If I did assign any of these, I'm sorry, and you could hate me for it. But it does stuff like this. X squared plus 5. It'll say factor by grouping, in which case what they want is the following, where you say, oh, well, we could group those together. There's an X common in each one of those, leaving me an X plus 5. Now, what could I pull out of this? Looks like I could pull out a 4. If I pull out a 4, what will I be left with right here?
X plus 5.
X plus 5. And I'm going to double check that. I'm going to say, if I multiply it back in, the 4x, yep. 4 times 5 is 20. Yep. That is the same thing as that. And then they say, aha, look at that. We could factor out an X plus 5. So I do that right there. That leaves me one X right here. 1 4 right there. And that's what they want you to do. The thing is, you're never going to see this. You're never, outside of this section in your math book, you're never going to be given a polynomial like that. That's never going to happen. You will be given a polynomial where those two things are combined, where you have 9x plus 20. That is, you're never going to see this in the real world. You're never going to spot that in the wild. It's always going to look like this, always. And so they kind of tell you to do this, but it's misleading because you're never going to actually do that. You're always going to be dealing with it like that, in which case, so I want to go into this. To factor a square, this is something squared, or, well, no, it's not a perfect square. To factor a parabola, or something with squared term here, we're basically going to unfoil. Okay, so the first thing we're going to do, and we've already gone through this. The first multiplication, right? We're unfoiling. We're going to un-F. Where did that come from? What must be here and here?
X.
X. Okay. Now, find out. Now, here's the thing. We don't know that it's 5 and 4. We know that it's 5 and 4 because we've just done this. But right now, there's more than one possibility. So what I like to do when I find L is first I'm going to list out what 20 is. Well, like the first thing I notice is 20 equals 2 times 10. That's one way I could write 20. What's another way I could write 20? How about 4 times 5? Okay, what's another way I could write 20? Is there another way I could write 20? I don't think so. Because that's 2 and 5.
So.
No, that's it. Because 20 is equal to 2 times 5. And there's only, that takes care of it right there. Oh, 1 and 20. Okay, that's another way we could do it. So what I do is now for this part, so find L. In other words, so what we're doing here is find possibilities. Find possibilities. Find possible ways to make L, which is basically what I was just saying. So we have a couple candidates. I'm going to start with doing, how about 2 and 10? And what I like to do is I like to write it right below right here. This is the kind of the method I've come up with. I test my Test a possibility. We know that when we're writing that down, well, the first is still going to give me x squared. The last, well, I wouldn't have written it there if it didn't multiply to give me positive 20. So there you go. Now we need to, we're testing a possibility by doing the outer and inner multiplications. So when I do my outer, we're imagining that we have x either plus or minus 2 and x plus or minus 10. And if I did my outer, what would I get? X times 10.
10x. Sorry.
No problem, no problem. If I did my inner, what would I get?
2x.
2x. Now I ask myself, is there some way I could add or subtract these from each other to give me 9x?
No.
No, I mean, if I tried to do a minus 2x, I would have 8x. If I added them together, I'd have 12x. If I put a minus over here, I would have negative 8x. No, there's no way of doing it. So we tested that possibility. There's no way by doing my outside and inside and adding them anyway is going to give me 9x. So I'm forgetting that possibility. Let's say I tried 1 and 20. What would my outside multiplication give me?
20x.
And my inside would give me what?
X.
Is there any way I could add or subtract those guys to get 9?
No.
No, the minus is going to give me a 19x. That's not going to work. I'm not even going to play with that. What about 4 and 5? What does my outside give me?
5x.
What does my inside give me?
4x.
Is there any way to add or subtract those guys to get 9?
Yes. You add them both.
I add both. And so that's kind of the last step here. Okay, so once we've tested our possibility and found it, then figure out your signs. In this case, it's obvious that they're both pluses. So I'm going to go, okay, plus 4x, or plus 4 and plus 5. The final step is check it. Please don't forget step 4, because it's so easy to mess up one of these guys and go, yeah, okay, I'm good to go. We're going to check by going first, outer, inner, last. First gives me x squared. Outer gives me plus 5x. Inner gives me plus 4x. Last gives me plus 20. All together, we have x squared plus 9x plus 20, which is what we had. So long story short, I don't know why in the world your book even presents stuff like this, because you will never, ever see this. It will always be like this. And if you have a nice method to unfoil stuff like this, we never need to worry about this anyway. You will need to factor by grouping with doing things that are larger than this. That is, when you have an odd power or a bigger power, it's nice to factor by grouping. But other than that, don't worry about it.
Okay.
I do want to do, I know we're like way over on time and I'm so sorry, but I do want to do one more like this using this method, because you're going to be doing this a lot. And I want you to see when figure out signs is not so simple. So we're going to do this. Okay, so same problem. Find. Actually, step 0 is write this. I'm telling you, it'll help you. It will so help you. If you think like to see this, it helps you to remember what you're doing. So what times what gives me that right there? What needs to go right there?
X.
X's. There's no other way, right? If it were a 3x squared, one of them would be 3x and one of them would be x. If it were a 6x squared, then I'd have a few possibilities. It'd have to have an x, you'd have to have an x, but now it could be 6 and 1, or it could be 2 and 3. Right? So again, there'd be more possibilities. You're not going to see these yet. We'll talk about that next time. I just want to kind of get that out there. Right now, we're just dealing with this type of thing. Okay, what about my last? What are my possibilities for 20? Right, so we found F. Find L by finding all the possible ways to make 20. 20 equals what?
4 times 5.
4 times 5,
2
or
times 10.
2 times 10, or
20 times 1.
20 times 1. And as you start to do these, right, even like you could kind of see like these numbers aren't going to combine to make that, right? But so
Right.
I have these written down and I'm thinking, I know what's going to happen. I know that the inner part comes, or this term comes from the outer inner multiplication. And I can already see that it's not going to be a very good guess to go 2 and 10, because I'm either going to get a 12 or an 8 or a negative 12 or a negative 8. That ain't going to work. 4 and 5, though, just might work. So let's just try 4 and 5. Okay. Now, the outer will give me what?
X times 5, or 5x.
5x. The inner gives me what?
4x.
Is there a way I could combine those to make a negative x?
Negative 5 plus 4.
Negative 5 plus 4. So that's what we need. Therefore, the negative has to be with which one of these numbers?
5.
The 5. And that's what I mean by figuring out signs, is that I know I'm going to put a 4 here. I know I'm going to put a 5 here. And I know that this term comes from the outer inner multiplication. And so if I need them to combine to give me a negative x, then the minus has to be here. But if the minus comes from this guy, then it has to go here. And so then that's the very last step I take, right, to figure out sign. That's why I save the signs for the very end and then say, okay, now finally, let's check it to make sure I didn't just reason backwards there in the end. First gives me x squared. Outside gives me minus 5x. Inside gives me plus 4x. Last gives me negative 20. Outer, inner, they combine to give me a negative x minus 20, and we are good. And so now I am certain that that is how we factor that guy. Sorry, we went over so far today, but that's me, I guess. So, okay.
Thank you.
Yeah. Okay, I got to give you homework. I know you can't wait for that. Okay. Okay. It's not too bad today. So, homework. Chapter 5, section 4, page 222 to 223. We're doing threes. Odd. So that is 19 through.
Why?
the odds from 19 to 49. Let me just make sure that I didn't. Oh, wait, not 23. Sorry. Not 23. Um,
No.
355. Would have been easier if I just wrote every single one out. I was like, I think these are all just in a row. Okay. 61, 63, 65. I think it's like 21 problems or something. And then finally, I'm gonna put a star by this one. That one. Oh, yeah, that one, factor completely. I told you in your homework from earlier, I was like, you might think you're done at this point, but oh, we could factor it more. That's that guy right there. We want to factor him completely. And ditto with 45.